All right, so this is the start of Lab 3. It's a lab on node voltage and mesh current. Right now we'll show you mesh current for figure 1 on your lab. And by doing this, we're going to use KVL, and we're going to show you the linear equations that you'll need later to solve what your currents and voltages are. Okay, so we'll start. You can see here there's 4 loops. We have 4 currents. We're going to start with I1. For I1, we have loop 1. Okay, so we have 5 volts. You can simplify this out to better factor your I1 and your I2. All right, and then we'll do the second loop. And we'll have 5,100 times I2 minus I1 plus 1,500 I2 plus 820 times I2 minus I3, all equal to 0. You can better factor this one out also. All right, and for the third loop, we will have 820 times I3 minus I2 plus 12,000 I3 plus 5,100 times I3 minus I4, also equal to 0. You can further simplify this one out also. All right, in the last loop, we have a voltage source in this, so we know it'll all be equal to 15 volts. 5,100 times I4 minus I3 is equal to 15. Oh, excuse me, equal to negative 15. You have to subtract it over because it was originally equal to 0. All right, and we'll further use these linear equations in a later part in the lab. All right, so this is the first part of the procedure, and we have our MyDAC hooked up to our computer using the multimeter. We've already constructed the circuit shown in figure 1, and we'll just show you what each one is before we start. So first we have our 5.1 kilo ohm resistor, next our 1.5 kilo ohm, 820 ohm, 12 kilo ohm, and 5.1 ohm. And then the red wire is our 15 volt supply, and the green wire is our 5 volt supply. We'll start by measuring the current for this, and to do that, it's in series. So the current between the 5 volts is 2.66 milliamps. And next we'll do the current going through the 5.1 kilo ohm resistor. And we see 0.94 milliamps about. Next we'll do the 1.5 kilo ohm resistor, your R4. And we get a reading of 1.70 milliamps about. Now we'll do the R2, 820 ohms. And we get a reading of 2.77 milliamps. Next, we'll look at our 12 kilo ohm resistor. And we get a reading of, and for the 12 kilo ohm resistor, we see a reading of negative 1.08 milliamps. Next, we'll do the 5.1 kilo ohm resistor. And we see a reading of 2.97 milliamps. And lastly, with the 15 volt source, we see a reading of 4.03 milliamps. Okay, so this is part 2 of Lab 3, and we're using LabVIEW to calculate the linear equations. First, we're on your front panel. You'll right-click, scroll to Array, Matrix and Cluster, and then over to Array. And you can place that on your front panel. You'll right-click again, scroll to Numeric, and to Numeric Control, and you'll place that in your array. Then you'll select your entire array, right click, and scroll down to add dimension. And then we're going to make it a 4x4 matrix. And so this 4x4 matrix is equivalent to the left side of your equations from part 1. And now we're going to make another matrix that is a 4x1, and it's going to be equal to your right side of part 1. Okay, so next we're gonna connect the nodes, but first we have to add a multiplier. Okay, so this is part 2 of Lab 3, and we're using LabVIEW to calculate the linear equations. First, we're on your front panel. You'll right click, scroll to Array, Matrix and Cluster, and then over to Array. You can place that on your front panel. You'll right click again, scroll to Numeric, and to Numeric Control, and you'll place that in your array. Then you'll select your entire array, right click, and scroll down to add dimension. And then we're going to make it a 4x4 matrix. And so this 4x4 matrix is equivalent to the left side of your equations from part 1. And now we're going to make another matrix that is a 4x1, and it's going to be equal to your right side of part 1. Okay, so next we're gonna, alright, so we're on the block diagram now, and we're gonna add an inverse matrix. So you'll right click, go to Mathematics, scroll over to Linear Algebra, and on the left side there's the inverse matrix. Alright, now we're going to add the A cross B, and we'll go to mathematics, scroll over again to linear algebra, and add the A cross B diagram. You can connect all these together then. Alright, we're going to add a multiplier to make your current come out into milliamps. So you scroll over to numeric and then over to multiply. And then from mathematics, we'll scroll to numeric again, and we're going to add the numeric constant. The numeric constant we set to 1000, and this results in a current of reading of into milliamps. Okay, so now you're going to right click on your multiplier. On the output of your multiplier, you'll hit create, scroll over to indicator, and you'll see a matrix pop up, and that will read your output. Now we're going to go back to the front panel, and we're going to insert the values of our equation that we put on the whiteboard in part 1. So our first value is 5,100. Then with I2 we have negative 5,100. No I3 and I4 in this loop. Next we go to I1 in the second loop, or I2 in the second loop, and we have 7,420. I1 is negative 5,100, and I3 is negative 820. No I4. The third loop, we're going to have no I1, so we'll go to I2 and we'll have negative 820 ohms. And with I3, we'll have 17,920. And then I4 is with negative 5,100. And the fourth loop, we have negative 5,100 with I3 and a positive 5,100 with I4. So that's for the right side, and then we go to array 2 for the left side. Excuse me, the first part was for the left side, the second part's for the right side, vice versa. And we have 5 volts with the first loop and negative 15 volts with the fourth loop. Alright, so now you can run your program. And from there, you'll see the values of your I1, I2, I3, and I4 outputted. These also match the values we got from measuring during the circuit. We measured 2.66 milliamps for I1, 1.70 milliamps for I2, negative 1.08 milliamps for I3, and negative 4.03 milliamps for I4. So we can see that they're pretty similar and almost the same.